Hello everyone, it's the Explorer here. The topic of today is the vector equation of a line. You're already familiar with the idea of the equation of a line in 2 dimensions, y equals mx plus c, where the gradient is m and the y-intercept is c. Now, when we want to try to specify a line in 3 dimensions, or in n many dimensions, things get a bit more complicated. We can give it in a Cartesian form in terms of x, y, and z, but it can be done with vectors. Vectors provide a really clear and quick way into our problem. We need to first ask how much information is needed in order to specify a line in 3 dimensions in vector form. The first thing that you need is a point on the line, right? First, I need to get onto this line, right? And then once you're on the line, you need a direction vector to move along this line. You move along so you can basically access any point along this line. And so the equation in vector form is r equals a plus lambda d. And I'll explain what each of these mean. All right? R is the position vector of some general point, and this general point we will denote as P. So in my diagram here, we can see there's a green dot, and it's a general point. So in this diagram, it's drawn in this configuration, but this P it's basically variable. It can be anywhere along our line, right? A is of course called, it's called an anchor point. So as I said, first, if you want to define the equation, you need to get on the line. You need to get on a point on the line. And that point we call an anchor point, right? Because it's from that point that we're going to move along the line. Now D, which I've written in blue, is a direction vector. What do I mean by direction vector? A direction vector is a vector which is basically parallel to this line that you want to define, right? And we can clearly see that I've scaled it. We've used a scalar parameter, lambda. It can be anything. It can be mu, it can be t, right, z, anything that you really want. But conventionally, in a lot of textbooks is written, we use the scalar parameter lambda, right? Lambda essentially scales d, right? For example, here, if we do 2D, we just scale it and it will look something like that, right, roughly. So, there's 2 things, right? You need to get on you need to get onto a point. So in this case, we're getting onto the point A. And then once we're on A, we can scale this direction vector however much we want. For example, if we want to get onto, let's say that P is here, well, we scale D proportionately. And of course, if lambda is negative, then we can get onto some point here. And then we can keep scaling it, and basically we can access any point along this line. That's that done. Vector equation of a line, right? Thank you for listening.